Ready to go with 5.7. This is division by polynomials. Okay, so division of a polynomial by a monomial is pretty simple. It's basically just canceling. But when we get to dividing by a polynomial by a polynomial, then it gets a little bit trickier. So let's go ahead and do the simple stuff first, kind of get you in line with what that looks like, and then we'll go from there. 10x to the fifth minus 15x to the fourth, example 1. And that's all over 5x squared. And what that means each of these terms is over 5x squared. It's not like you can go up here and cancel this one here with one of these, because each one of these is over the 5x squared. So one of the things that I do, and the book does it a completely different way, but you know me, 5x squared. I'm going to do something kind of odd. I'm going to put that 5x squared under each one of those. Now all I have to do is reduce. 10 over 5 is 2. X over 5, x to the fifth over x squared. Remember, when you divide exponents, you subtract. 5 minus 2. 15 over 5 is 3. 4 minus 2 is 2. 20 over 5 is 4. X to the third divided by x squared is 3 minus 2 is that. Now look at the book and look at what I did. Big difference as far as how much work is involved there. But what I did is kind of a cheating way. Really, you should have this like erased here, so you have 3 different fractions, because that's really what we did. But it's a little bit more difficult to just erase for you guys. So let's do example 2. Okay, there's example 2. I'm going to do the same thing. I'm going to put a negative 2x squared y there and a negative 2x squared y there. And I'm going to, this time I'm going to erase there. And we just go and cancel each one. So 8 over negative 2 is negative 4. X cubed over x squared, 3 minus 2 is 1. Y to the fifth and y, 5 minus 1 is 4. Okay, 2 negatives give me a positive. 16 over 2 is 8. X to the second over x to the second is 0. 2 minus 2 is 0. So that goes away, and y2 minus y is 1. Whoops, I've got a minus sign there. Okay, I got a minus sign because of that. So I guess I could change this to a plus and do the negative 4 over negative 2 is negative 2. And x to the fourth over x squared is x squared. Y cubed minus y, or divided by y, is y squared. And then I look at this plus and minus, and I'm just going to make this a minus. And I'm done. Okay? So not too terribly difficult with the monomials. Let's try example 3, and then we'll move to dividing by a polynomial. All right, there we are, example 3, and let's just play this little game here. And because I can, I'm going to go ahead and erase this. Makes it a little bit easier for me to erase than most people. Okay, so let's do 10 over 4 is actually 5 over 2 if you were to reduce that fraction. A to the fourth over a is a cubed. And b over b squared over b squared, that goes away. So that's all we have in that first term. 8 over 4 is 2. The a's cancel. And that gives me a b, because 3 minus 2 is 1. Minus, and I'm going to get a different answer than the book because their problem had a 2 on the A, and I neglected to put that on there. So my answer will be different than the book answer, but it's still following the same procedure. A cubed over A is A squared. B over B squared is 1 minus 2, which is negative 1, and we'll get back to that in a minute. 6 over 4 is 3 halves. Whoops, that's not a half. A's disappear, and we have b to the negative 1 there. All right, so whenever we have a negative exponent, remember we move it. It's just telling us that it's in the wrong place. It should not be in the numerator position. It should be in the denominator. So let's go ahead and move it to the denominator position here. Now it's in the right place. And we're going to move this one to the, whoops, that's not my eraser. We'll move it to the denominator position because of that negative. Boy, that made it thick, didn't it? There. So 3a squared over b. And again, it's going to be different than the book because I copied the problem down wrong. But anyway, that's how you do that. Okay, so let's get, let me at least bring up something to remind you of the negative exponents. If I had 2a to the negative 1b, that means that the number or letter to the left of the negative and the exponent that the negative is on are in the wrong place. Right now, it's in the numerator position. That negative is telling you that it shouldn't be there. It should be down there. And as soon as you move it to its rightful place, the negative goes away. So it's a to the first power, but you don't need to write the first power there. So that's what happened with the second two terms there and why they moved around a bit. All right, so dividing. In this particular case of example 4, what we're going to do is, first of all, we're going to look and see if there's anything familiar here. Yes, there is. This is a trinomial, and that trinomial can be broken down into two binomials. All right, so what I'm doing is I'm looking for two numbers multiplied together that give me 7y. So a y times y is y squared. So I just put a y in there. I'm not worried about that. I'm trying to come up with the number. Multiplied together gives me a negative 7. The only two numbers that multiply together give me a 7 is 7 and 1, because 7 is a prime number. Fortunately, when we take negative 7 and add 1 to it, we get 6. So therefore, that ends up being our equation, or our factoring, and then we put this down there. And notice this cancels with that. So our answer, our factored answer, is right there, x minus 7y. So when you do have a trinomial like that, always see if you can factor it first, because if it does factor and you can cancel things out like this, that's a good thing. In these problems, not going to happen that way because they want you to practice actually dividing. So what they do for example 5 is they do an old-fashioned long division problem just to kind of remind you of what this looks like. It's been a long time. And since we have calculators, you don't have to use long division very often, but you're going to have to in this section. You can't just, I don't care that the answer is 185 with a remainder of 3 over 25 by putting it in your calculator. You need to remember how to do it the old-fashioned way. So I'm also going to put beside this a division of a polynomial by a polynomial, And the reason for that is it's very similar. The long division you do just with numbers over here is very similar to the long division you use with polynomials here. So let's give this a shot. So 25 goes into 46 one time. And where do you put the 1? You put it over the 6. And that's what we're going to do over here. We only divide the x. We use the -2 later, but the only thing we really worry about is the x. How many times does x go into 2x squared? Well, let's look at this. 2x squared divided by x. What do you do here? It equals 2, and then remember 2 minus 1 is 1x left. So x goes into 2x squared 2x times. So another way to look at this, come on, is, and this might be the kind of the cheater's way, is I look at this and I compare it with the x here. I have 2 of them here, I have 1 of them. 2 minus 1 is 1x. I can't do anything with the x and the 2, so the 2 never changes. So I get 2x. So where do I put the 2x? I put it up here. Why do I put it up here? Because there's an x here. I try to keep these stacked. If this was an x squared, if I got an answer of an x squared, I'd put it over here above the x squared. So we try to keep these columns here. In fact, let me make a column here because we are going to end up doing that all the way down. All right, so 25 went into 46 one time. X goes into 2x squared 2x times. What do we do next? 1 times 25. What do we do here? 2x times -2. Just make sure you put it in the right place, in the column with the x's. And then 2x times x, 2x squared. Now, one thing that makes sure you understand, when you multiply this times this x here, you have to get the exact same number. If you don't get the same number, you did something wrong. You absolutely must get that same number. Okay, let's go back to the number here. Then you draw a line, minus. You draw a line, minus. Then you subtract. 6 minus 5 is 1. 4 minus 2 is 2. Okay? Do the same thing over here. -7 minus -4 is the same as -7 plus 4. Okay, that is huge. If you do not put the negative sign there, it will screw you up big time. That has to be there so that you know if you have a negative here that you add. -7x plus 4x is -3x. This goes away. 2x squared minus 2x squared is 0. You will always get a 0 here. Come over here to our numbers. We bring down the 2. We bring down the 9, but we bring the sign with it. Okay? Now what do? 25 goes into 212 8 times, and the 8 goes above here. Do the same thing here. X, again, x only divides. We divided x into this. We divide x into this, just like we divided 25 into this. So x goes into -3x, 1x there, 1x there, so they disappear. So we just have the -3. Notice there are no variables here in this column, and there's not one up here. So we've got the -3. Now what do we do with this 8 here? Multiply it by the 5. Carry the 4. 8 times 2 is 16, 20. Line, negative. Do the same thing over here. -3 times -2, +6. -3 times x, -3x. Again, these have to match. Line, minus. -3x minus -3x is -3x plus 3x is 0, so that works perfect. 9 minus 6 is 3. So once we have brought down all of the numbers, we are done. So we have 3 there, which means we have a remainder. So our answer is, the 3 is a positive, plus 3 over that. So that ends up being our answer, 2x minus 3 plus 3 over x minus 2, which means that this does not divide evenly into this, or we wouldn't get a remainder. Because we get a remainder, this does not divide evenly into that. Okay, so that's how you do those. We're going to do a couple more just to make sure you're following this, and it will, sorry guys, never get easy to do. But it's something that's necessary if you go on to higher level math. In fact, I think we probably get into this later on in this book, that it's very, very important to know how to do this long division. So I'm going to stop here and go to the next video.